Hello, everyone, and welcome back. We are about to begin a new unit on ratios and rates. So I think we are sort of dividing this unit up into two parts. For the first couple weeks, we'll work on ratios and then eventually take a quiz. And then the next couple work on the rates part of it and do a quiz. So we're sort of dividing it into two sections. Okay? And one of the big questions we want to be able to answer is written here. How can we write a ratio to compare quantities or amounts in a situation? And what does that ratio mean? Now, some of you may be familiar with the term ratios and some of you may not be. So let's start by doing a little explanation of what a ratio actually is. A ratio shows the relationship between different amounts or quantities. So when we look at this picture here, we can see some red cars and some green trucks. So if we're asked to write a ratio comparing cars to trucks, we could write a ratio, we would say there is 3 cars to, if we count, there are 5 trucks. So one way to write a ratio is to use the word to in there, to. Another way you can do it is you can put a colon in between. 3 cars to 5 trucks. These are both considered ratios. And the third way is to write it as a fraction. 3 cars to 5 trucks. Okay, there's 3 different ways to write a ratio. But what does have to happen is because car is written first, the number of cars has to be first in all of these. In this one, in here, and in the fraction. And trucks is written second, so the number of trucks, which is 5, is second in all of these examples. Your word to is sort of usually in the middle between the two objects you're comparing, the cars to trucks. So that's where the word to goes, or the colon, or where your fraction bar goes. Okay, so there's 3 different ways. I will tell you that the colon is probably the most common way. And then the word to, okay, and then lastly this one. Most people, but those are all 3 ways that are acceptable to write a ratio. Okay, but again, order does matter. You have to do it in the order of your statement here. So let's look at another example. Okay, we can see pictures of strawberries and pictures of oranges here. So the first one, we're asked to write a ratio of strawberries to oranges. Again, look at the order. Strawberries is first. Here's my word to, and then oranges. So if we count the strawberries, there is 6 strawberries to 4 oranges. And again, you could also put the word to in here, 6 to 4, or we can write it as a fraction. Any of these ways would be acceptable. I tend to use the colon a little more, but any of those are acceptable. The ratio of oranges this time, oranges is first, 2 strawberries. So if we count our oranges, there's 4 oranges and there's 6 strawberries. Right? It's just reversed. Again, we could write that as the fraction, 4 over 6. Or I can write 4 to 6. Write the word to. Any of those will work. Okay, let's look at the last one. The ratio of oranges to all fruit. Okay, so let's look at what we want. We want oranges. So we know there's 4 of them. To all fruit, it says. So this one's a little different. So now, in order to get all the fruit, we need to total all of these up. So we know there's 6 strawberries and there are 4 oranges. So that would be a total of 10. So I would write for this one 4 to 10. Again, or I would write the fraction 4 over 10, or you could write 4 to 10. Any of those are acceptable. Okay, so again, order matters. You can choose any way to write them, totally up to you, but the order they go in does make a difference. Okay, here's a third example for us to look at. There is soccer balls, there's basketballs, and footballs in this one. Okay, so let's look at our first question. So we need to write a ratio of footballs to basketballs. Okay, so if we count our footballs, we should find that there is 8 of them. And basketballs, there is 3. So I'm just going to use the colon for this one, but you are free to use any of those other methods if you like those better. Okay, now another thing to note is that at times you may be asked to reduce a ratio. And you would do that just like you would a fraction, by finding a number that goes into both of them, 8 and 3. In this one, I don't know of anything that can go into both 8 and 3 to reduce it. So this one cannot be reduced. So let's look at another one. Ratio of soccer balls to footballs. So if I count the soccer balls, I know there's 4. Right? Footballs is 8. Now, this is one that I believe we can reduce. So if you were asked to reduce this, I would need to find a number that goes into 4 and 8. Well, we could do 2 because it's even, but I think a bigger number that goes into both is 4. So we should be able to divide both of these by 4 to reduce this ratio. So 4 divided by 4 is 1. And 8 divided by 4 is 2. So the reduced ratio is 1 to 2. Okay? So if you're asked to reduce, it's just like you would a fraction. And our third question here says basketballs to all of the balls. Okay, so let's count. So basketballs, I have 3. And all of the balls, if we count, well, we know there's 8 here, and 4 is 12, 13, 14, 15. So we have 3 to 15. So again, if you were asked to reduce this, we would need to find a number that goes into both 3 and 15. And there actually is one. We could divide both of these by 3. So 3 divided by 3 would be 1, and 15 divided by 3 would be 5. So the reduced form would be 1 to 5. Okay, so we should be able to write a ratio and reduce it if necessary. Another thing to be aware of is that not everything can be written as a ratio. In order to be able to write something as a ratio, they have to be measuring the same type of thing. For example, we were measuring in the last one different types of balls, basketballs and footballs. Okay, so let's look at these. And when we do this, we focus on their units. Let's look, not the number, look at the units. This one is measuring centimeters, right? And this one is about seconds. So think about what these mean. Centimeters means you're measuring the length of something, right? How long something is. This one is focused on time. They are not the same unit, or could be changed in the same unit, because they are measuring 2 different types of things, seconds and time. So this one could not be written as a ratio. No. Okay? Look at the second one here. 3 days and 12 hours. Think about what these units are measuring. This one is measuring time, right? This one's measuring time. And if we look at 3 days, that's also measuring time. So yes, these are measuring the same thing. And down the road, we'll talk about converting these so that they are both the same unit, but this one could be done. They are measuring the same thing, yes. Let's move on to the third one here. It says 9 grams and 15 millimeters. Again, we're not worried about the number. We're focused on the units. Grams. Hopefully you know from science class that grams measures the weight of something, how heavy something is. Okay, this millimeters is measuring length, how long something is. So these are not the same units. So this one cannot be a ratio. Okay, finally the last one here, yards and inches. Okay, when you're thinking of yards, think of a yardstick. That helps you. You're measuring length or how long something is. Inches also mentions how long something is. So these are measuring the same thing. So yes, they could be a ratio. Okay, so something to consider when you're writing them is that they have to be measuring the same thing. Okay, so we had worked on writing ratios using pictures, but we should also be able to write a ratio from a situation. So let's look at in the red up here. This one says there were 55 adults and 34 children at a party. Okay, so we are asked to, in part A here, find the ratio of children to the number of adults at a party. So again, we're comparing children, and there's my word to, adults, right? So if it helps you, I would say, okay, I'm comparing children to adults. So now let's look for the numbers. Children is 34, and it has to be written first because it is first in the question that was given to us to solve. Adults is second. It's after the word to here, and it tells us there's 55 adults. So my ratio would be 34 to 55. And again, if you wanted to use the word to, or if you wanted to write it as the fraction, that's totally acceptable. Okay, let's look at part B. Find the ratio of adults to the total number of people at the party. So let's look at what this one is asking. Adults, there's the word to total number of people. Okay, so we are doing adults to, I'm just going to put the word total here to help us know what order things need to go in. So adults to total. Okay, it tells us that there was 55 adults. So we should be able to fill that in first. 55 adults, right, to total number of people at the party. Now, this little statement does not give us the total number of people, but we should be able to figure it out, right? If there's 55 adults and 34 children, if you take these two and add them together, right? If I add 55 and 34, I'm going to get 89. That would be the total number of people at the party. So my answer to this question is 55 to 89. Again, make sure you're writing it in the correct order. Adults first to total number of people. Let's look at a second one. Keith and Liam baked 108 oatmeal bars. Keith baked 40 of the bars. Okay, so there's your situation. Let's look at part A. Find the ratio of the number of oatmeal bars Keith baked to the total number that Liam baked. Okay, so let's see what we want. We want Keith to Liam, right? So Keith is first to Liam. That should be our order. All right, so we know that Keith and Liam together baked 108, and Keith made 40 of them. So I can write 40 under Keith, but it doesn't come out and tell us how many Liam baked. But we should be able to figure that out. If together they baked 108, right? And Keith made 40 of them, if we subtract, we should be able to figure out how many Liam made, right? And that would be 68 of them if you're subtracting here. So Liam made 68 of the bars. So our ratio would be 40 to 68. Okay, that would be your correct answer there. Look at the second one. Now it says, find the ratio of the number of oatmeal bars Keith baked to the total baked. So let's dive into the statement here and figure out what it wants. So it wants the number of oatmeal bars Keith baked to total number of bars baked. So it wants a Keith to a total. Right there, that should be the information that we are looking for. And in this one, Keith baked 40. It told us that. So I'm going to put it over here just so I have a little room here, guys. So 40 would be first, and then I need a total number of bars. And this one actually tells us Keith and Liam baked 108. So my total is 108. So my ratio would be 40 to 108. Okay, last one here, guys. This one says Sue baked 36 chocolate chip cookies, 40 peanut butter, 30 oatmeal, and 45 raisin. Okay, there's your situation in the red. Now it says, find the ratio of the total number of oatmeal cookies to the total number of raisin cookies. Okay, so we want oatmeal to raisin. Right? That's what we want. We want oatmeal to raisin. There's my O and my R, just to help me organize it here. So oatmeal is 30. And raisin, if we look, is 45. So it would be 30 to 45. And again, some questions may ask you to reduce that. I'm not asking you to do that here, but you may be asked to reduce this and find a number that would go into them. Let's look at question B. Find the ratio of chocolate chip cookies to baked, to the total number baked, sorry. So we want chocolate chip, I'm just going to abbreviate here, to total. Right? Chocolate chip to total. So if we look at our problem, it tells us right here that there was 36 chocolate chip. So we know that. But now we need a total number of cookies baked. Okay? I don't see anywhere in the statement where it says a total number baked, but we can figure it out, right? If we add all of these together, we should be able to figure out how many total cookies were baked. If I add all those up, I would see that there was 151 cookies that were baked. So my ratio is 36 to 151. So today, guys, we have focused on a little bit of an introduction to ratios. We focused on three main things. We said that in order to be able to write a ratio, it has to have the same units. They must be measuring the same thing. Right? It has to have the same measurement. We also worked on writing them. We said that we could put a colon in between. We said we could put the word to in between. Or we could use it as a fraction, 3/6. Okay? And we can also reduce them. If my ratio was 3:6, we should say, hey, I could divide both of these by 3, and I would go down to 1:2. So those were the three main things we focused on here today. Okay? You do have an assignment on Schoology to practice these items. Feel free to use your calculator if you need it, and send us a message if you need anything. Okay? Have a great day, guys.